All right, Java 4 lesson 2. We're doing constants and interface today. You guys probably heard me mentioning like constants during when we were reviewing, and that is part of what we're doing today. All right, so there's this random piece of code. There's like stuff though. So constants again are regular variables that can be changed to whatever value we want. So normally with like a regular integer variable, right, we're able to change it. So for example, if we said int sum equals 5, then later on we're able to change it to something else. So we can say later sum should equal 15 now instead of just a 5 from before. That was all legal and everything, and Java never like threw an error at you because of that. You were able to do it very freely. The thing with constants is that there are variables that cannot be changed once it's set. And sometimes it might be like hard to see why this is like something that we want to do, but I can explain it a bit later. There are purposes for it. Constants can go everywhere except on its own. So like essentially you can put it in a class. You can put it in an abstract class. You can put it in a generic class. You can put it in a static method. You can just put it in the main method. So that all works. It's just that you cannot put it like outside of a class, essentially. Yeah, otherwise they work exactly the same as regular variables. The main thing is just that it cannot be changed once it's first created. This is how you're going to set it. So the thing is, right, if we just ignore the final part and we just look at the double pi equals 3 pi 1 4, this looks exactly like what we would expect a regular double variable to look, right? It's just that. The only thing that's changing here is the fact that we're adding a final here now. So the keyword constants is final. So whenever you want to signify to Java that you want to have one variable be a constant, then you want to add this final keyword right here so that Java knows that it's a constant and we'll keep track of that. And so when we are just putting pi out, it outputs 3.14. So yeah, again, it works exactly the same. This pi part is your name of the variable. And so that's why when we're saying pi here, it will just, like regular variables, print out whatever that variable holds. So in this case, it's 3.14. Just curious. Never mind. I'll ask it later. Okay. Anyways, naming conventions. So there are specific naming conventions for various things. So for example, you know how variables, it's usually best to keep the first word lowercase and then make it so that every single word after that, the first letter is capitalized. There's also naming conventions for constants that you might want to know of just in case, because if you're going to go into an industry and then you're like reading people's code, then sometimes if people use certain naming conventions, then usually you'd be able to tell like what they're supposed to be coding. And then also, I don't know, it's just something you'll see very often in coding. So it's good to know just so that when you encounter that later, you're good with it. Yeah, so constants are usually supposed to be worded with all capitals. And if there are breaks between words, they should be signified by underscores. So you could see in the previous example that this pi right here, I did PI all capitalized. That should be kind of what you wanted your letters to all be. And the things you can and can't do are the same as with regular variables, and that is explained here. So good names. Name of student. You can see that all of the letters are capitalized and that with the separation of words that we're putting underscores between them. And if you not sure where the underscore character is, it is usually next to the 0, right under the dash, the hyphen. Yeah, this is a good name, usually. There's pi, like we were doing before. Jokes, if you wanted to do a longer one. And again, just note that it's all capitals. Not as good names. Student. So because it's not capitalized, again, like this isn't going to give you an error or anything, but like generally it's not like going with the naming conventions, which isn't as good. So like it works, Java's not gonna like complain about it, but like for other people looking at it, it might not be as good. Sum for addition. There's two things with this one. Number one is that it's not capitalized. And number two, it's that it's all squished together, right? Like you can't tell, it's very hard to see what word is what. And there's like no underscores to separate the words. So that's the main things with that one. And there's also this one. So this one Java is going to complain about because of the fact that remember that we cannot put a number as the very first thing in a variable. You can put it in later, like you can put it like you can say name of student 2. That works, but you just cannot put a number as the very first thing that is in a variable name. Therefore, that is why that is wrong. So Java's going to complain about it. And it's also not going with the normal naming conventions. And lastly, this one. This is also supposed to be one word, but it's separated by spaces. So Java's also going to complain about this one because of the fact that there's spaces between the letters, and therefore, like, Java doesn't know what is the name of your variable, right? So no spaces, and also make sure you're conferring with the naming conventions. Purpose of a constant. So the thing with this is that if you try to access constant after you declare it, so like trying to change pi to like, I don't know, 10, let's say, then you will get an error because it's not allowed. And it just kind of like acts as a error checking kind of thing for you. Because otherwise, when you start coding like thousands and thousands of code, like lines of code, then it's hard to differentiate between like what is supposed to stay the same, like the number 3.1415, like pi, or like e if you want to do that. It's hard to differentiate between like what is supposed to stay constant and what is not supposed to change. So a lot of times it's really nice to just make it so that it will give you an error if you do something with it that you don't want. Yeah. Again, this happens when the set value that you don't want to change, such as pi or e, because those are like set values in mathematics. Like you probably don't want to change this if you're going to use those. Again, by making it a constant, you're preventing yourself from accidentally changing something later on in your program and causing errors. Because syntax errors or like exceptions that happen are very easy to see, right? It stops your program, it doesn't run anything. But if you have a semantic error, which is a logic error, that gets a lot harder to see because like you're like, why is this doing this? And then you have to go through like thousands and thousands of lines of code to try to find the error, which isn't something that you want to do. So therefore, constants can be really useful. Okie doke. So now we're getting to a part where we're looking at code examples. So an interface is a class that can only contain constants, static methods, and abstract methods. So we're kind of like switching on to a sort of different topic now, but it's still related to constants in a way. Okie doke. Something that I want to know is that like interfaces, I sometimes like to think of them as very similar to abstract classes. And the fact that it can contain abstract methods, and it's also like kind of like a template for other classes to base their own classes off of. Okay, I am gonna go and give you guys access to this. I should probably not. Give me a second. I'm gonna share the link to this document here in the chat so that you guys can go see. There you go. So go hop on the document. And you can see what I did with this again is that I kind of just did all of this code, right? And then I just commented on different parts to make it easier to understand what is what. And the first example we're just going to go through is the general interface example. You guys can see the comments, right? I made it so that you get some commenting access. So hopefully that means that you guys can see. Oh, wow. Okay, never mind. All right. So just quickly, I guess. Yeah, there's not much that like you guys can determine the output of, but so generally kind of going through this, let's start down here first. So this is creating an interface random, and this is like very typical of a lot of things we do with creating classes and like abstract classes and things. Just state a keyword, so in this case it's interface, and then the random part is a name. And then after that we have brackets to separate it from everything else. Inside here you see that I said that this creates a void, a public abstract void method named display. So the thing with this is that it probably looks kind of weird because it's like there's no like public there, right? Like usually instance methods would have like a public there, right? But the thing with interfaces is that like it shortens a lot of things for us. And the fact that you do not have to put public or abstract keywords there in front of the method, because it automatically assumes that like what your method is a public abstract method. So therefore, if you wanted to like shorten the time that you take to like write your code, then you can just put the return type. That's always important. And the name of the method, which in this case, it's display. You always need your parentheses to detail any parameters you have. And then you have the semicolon at the end. That is typical of abstract methods. So yeah, when you look at this, don't be fooled. It is a public abstract method. This one here, though, is something that we specifically specify. So this time we're specifying that it should be a static method, and therefore we place static here. I don't place a public there because it still assumes that like it's a public method, even though we changed, we specified that's supposed to be a static method. So it's a static method. I have an integer return type, and then a method name of repair. And then inside here, I'm just returning 507, which is just 12. All right, so that's that one. Then we get on to the actual class, and this is like a regular class. The thing with this that is different with like something that is, we're just going to zoom in a bit, something that's different from abstract classes and other ways that you use inheritance is the fact that instead of saying extends here, we're actually saying implements. So that's one other kind of key feature that you want to note when you're using interfaces is the fact that we don't use extends, we use we use implements. And so therefore, always note that when you want to use an interface, use implements, the keyword to specify that. But otherwise, that's pretty similar. You just have the interface name here that you want to use. This should be pretty familiar content. We're just creating an integer size instance variable. We're setting it inside of the constructor. Over here, I'm just saying an override. Again, you don't have to use it, but like I just did it anyways. And then here, like we do with all other abstract methods, we're just overriding it. So we have a display method here for abstract method in the interface, and we still have to override the abstract methods here. And so that's why I have a display method. Remember that just take note that we're now putting the public back in. So make sure to do that. You can't just do void display again. Please make sure that you're putting the public in, just so that Java doesn't like yell at you or anything. Yeah, otherwise the void return type is the same. The display name is the same. And then we're just adding a method body to it, which in this case, we're printing out sides. And one thing to note here that is, if you wanted to, you can put public abstract here if it makes you feel better, or like if it's easier. I just didn't put it in here since it didn't really need to. Yeah, you can put it if you want to, the public abstract part. Besides that, here we're just creating a shape object of the name S, and we're saying that sides should be set to 5. We're saying s.display, which is calling the display method of the S object, which goes down here to this display. Again, we're just printing out sides. So it should just print out a 5 since sides is 5 in this case. And lastly, just a kind of a refresher, but the way we call static methods in like different classes like other than this main method over here in the public class, is we do the class name dot repair, like the method name. So therefore we're saying, okay, we want the repair method from the random interface. So we go to the random interface, we go to this repair method, and then we just run this method. And in this case, it returns a 12 because that is what it returns. It prints out 12, and then we're done. Scale of 1 to 10, how much does that make sense? All right, nice, Jeffrey. Tony and Chloe? Alrighty. Chloe, let me know. Okay, sounds good. So there's another example down here, but we're gonna like wait on that because I'm gonna come back to it later. Going back here. All right, there we go. Declaring interfaces. So again, the methods of an interface are automatically public and abstract, so you don't have to put it in manually, the keywords that is. If you wanted to make a method private though, or like protected, that still works. It's just generally like if you don't put anything, then Java's just going to assume that it's public and abstract. For static methods, you would have to write out the whole method instead of just the declaration. And by that, I just mean that there's a difference between abstract methods and how you create them first. And there's a difference between static methods and how you create those. With static methods, you have to put like something inside of curly brackets after it. With abstract methods, you can just put the initialize the declaration line and then leave it until later to put the body in. When implementing this interface, you would not be required to override the method like with abstract methods. So by that, I mean that you don't have to override the static methods inside of an interface. It's fine if you just leave them there. You can if you want to, though. I mean, but like you don't have to. And again, static methods are called differently from instance methods, and they cannot be passed on through inheritance. So therefore, if you try to call a static method from a subclass of an interface, that does not work because static methods are just not passed on through inheritance at all. Inheritance only involves instance methods. So therefore, that's something that you should note. Always call it through first saying the name of the class or the interface, and then dot whatever method you're running. Variables are automatically set as constant, even without manually declaring them as a constant. I put a final there just because it makes me feel better. But yeah, you don't have to put the final keyword there if you're using it inside of an interface. Everywhere else, though, you're going to have to specify that it's a final, like it's a constant, though. But just inside interfaces, you can like leave out the final if you want to. You can also implement multiple interfaces at once. Just be sure that you're overriding all of the abstract methods if there is any. So, for example, if we have an A and B interface, then a declaration line, if you have a regular class that wants to implement them, is something like this. So class, the name of the class, implements, and then just the first interface you want to implement, comma, and then the second interface. And this can go on, like you can like put another comma here and then add a C interface and then add another comma there and add a D interface. It can go on like that. It might not be the best thing to do, but it works. So that's something that you can take note of. Besides that, create an object for an interface. as the X says, this would not be allowed, similar to abstract classes. So do not create an object for an interface. It does not have a constructor. It can't have a constructor because, again, it can only contain three things: abstract methods, static methods, and constants. It cannot have anything else such as a constructor. So therefore, it would not be allowed. Methods, static methods, you call directly from the interface. Abstract methods, again, you would override the abstract method subclass and then call the method from an object of the subclass. Otherwise, if you wanted to extend both a class and implement multiple interfaces at the same time, that works. And these are the specifications. So a single class can only extend up to one class, but there's an unlimited amount of interfaces that it can implement. So yeah, an example of a declaration line would be something like this. So class, the name of your class, extends. Again, extends means that you're using a class shape, which is another class. Implements A, B. In this case, A and B are interfaces. Again, notice that the extend is before the implements. It should always be before the implements, and there will be an error if you switch to. So be careful of that. Always do first the class and then the interfaces. For calling a constant directly from an interface, same way you'd call a static method. So for example, if you had a constant that is named as sum in an interface, then you would just use random, which is the interface name, period, constant name. So in this case, it's sum to call it. And I know I'm going a bit fast, but let me know later if you want me to specify anything a bit clearer. All right, so it's always when you're calling a constant directly from an interface, whatever the thing it is in, so like an interface, period, then the name of the constant. So though this might be different if the constant is private, because again, private means that it's only referring to the class it's in or the interface it's in. So if it is private, then you're not able to call it outside of the interface, but otherwise you are able to. You also can't do private constants inside interfaces anyways, but just a note. Yeah, you can also call a constant through an object of the interface subclass. Okay, that sentence doesn't make sense. But essentially, because constants are passed through inheritance to the subclasses of the interface, that means you are able to call a constant through the subclass of an interface if you wanted to. All right, let's see, just checking the example again. Okay, that works. So I kind of want to finish the extra notes part after we're done with this, then we can do the last code example. Right, so extra notes, just finally. So if you have subclasses off of a superclass that implements an interface, so the superclass implements an interface, then the subclasses will automatically implement the interface. So you don't have to repeatedly implement it again and again because it's already implemented because your superclass implemented it, if that makes sense. So yeah, similar to with a lot of other things. Subclasses don't have to override the methods in the interface because the superclass should have already done it, and the subclass will just inherit the overridden method, so you don't need to override it again. You can also have interfaces implement interfaces with the extends keyword, and I get it's kind of confusing, but so if you're a class and you're trying to inherit something from an interface, then you're using the word implements. If you're a class that wants to use another class, then you're using extends. If you're an interface and you're trying to get use another interface, then you have to use extends. Trust me, like it's difficult, but I think, yeah, it might get clear later on as you start to program more. Also, interfaces cannot extend classes, so don't do it. But also it's kind of a thing because like interfaces, they don't have constructors, right? So it can't really take anything in the constructor from the superclass, that is. Anyways, let us go through. I am going to pause recording in a second, but yeah. So there is the code examples here for the people watching the recording later. Then try to go through these and see if you can piece out like what each of these compartments mean and try to determine the output because it's a good exercise. Yeah, I think this will be pretty much all we're doing for the rest of the class. Right.